Uh, Good afternoon. I'm absolutely delighted to be here and enjoying the wonderful presentations and learning so much from you all. So I hope I can contribute a little bit. I'm going to speak about data as infrastructure and challenge some questions about what we mean by infrastructure and who's doing it. For 5 years, I was chairing the Smart London Board for the Mayor of London. It was the very beginning of having a Smart London Board, straight after the Olympics in 2012. And Boris Johnson asked me to put a board together, and I reported to Boris Johnson. I could do the after-lunch talk about what it was like working with Boris Johnson, but that wouldn't get us into too much of the engineering stuff, so I'll leave that be. Look, I'm going to cover off very quickly on technology, think about demand, and then look at the supply side and the consequences for skills and employment, and what we mean by civil engineering perhaps at the end. There's a new economy. And I haven't heard it talked about today, really, not very much anyway. And the new economy perhaps is being driven by machine learning and what some people call artificial intelligence. And it's changing the world around us rather rapidly. So 60 years of computing gave fundamental economic changes because computing cut the cost of managing and sharing information. If we try and understand the economics of machine learning, we can start to see that it's cutting the cost of gaining insight and improving predictiveness. And in some areas, it's starting to think for us. And the economics of that is very powerful, and I want you to try and bear that in mind. I mean, there's two graphs here showing upward direction, almost exponentially, from The Economist, looking at the liftoff in a very short period of time of stuff that was in our Imperial College labs and Cambridge and other places for the last 50 years called artificial intelligence. It's now in the street, it's in our phone, it's happening to us as we're engineering. It's stuff that you can't see easily. And all the images of wonderful engineering projects are great to look at, but you don't see the data very easily. And we're starting to build new chambers, new visualization suites. This is the Imperial College Data Sciences Institute's Data Observatory, which when we built it 2 years ago was the most pixelated observatory in Europe, perhaps in the world. We could mobilize more pixels showing more data and do more manipulative stuff visually with visual analytics than anywhere. And it allows us to share, it allows us to collaborate, it allows us to rehearse, very important, so we can practice before we do it physically, connect, and sometimes to predict what might happen when we're engineering, and certainly to customize. So that's the technology set and the bit I want to say about it for my talk. What's happening on the demand side? When we started the Smart London Board, the word smart cities was bouncing around the place, a bit like the word innovation does. And we said, let's try and concretize that and tackle real problems in the city. And the little four-letter word popped up. It's called peak. I'm not talking about the peak in Hong Kong. I'm talking about peak load. And for most utility and infrastructure operators, peak load is the thing you want to avoid. It's the thing that upsets the regulator. It's the thing you have to have spare capacity, which is capital set idle, to deal with when it happens. And it upsets the customer. It's the traffic jam. It's the outage. It's not being able to get onto the Wi-Fi system, get on the train, get on anything. It's the hospital waiting queue. It's the water dump from extreme event weather that the rainwater goods couldn't collect. That's peak load, right? And so we see peak everywhere now. And I used to work on manufacturing. We used to think about lean production. And I used to think about lean everywhere, even putting toothpaste on my toothbrush. Now I look at peak in the same sort of way. And so what we did in the Smart London Board is say, let's try and have a look at peak. And what we quickly found was that each silo was pretty good at understanding itself in its own right, but it wasn't looking at the perturbations it was causing to other parts of infrastructure. The electric vehicle is a case in point. So as we see more electric vehicles come onto the street, the transport network has a direct play with the electricity network, yet most authorities don't have the data to share to understand that. So if everyone plugs their cars in the morning when they go to work, they put a spike on the electricity line. We know that now. Modelling at Imperial College has looked at this. We've worked with car manufacturers. You can smooth that peak by having intelligence in the vehicle. So in my Tesla, When I bought a new adapter to plug into a different network, there's software just in the socket that can read how much electricity I need to take, depending on how long I'm parked there. We know that sort of thing. So this is about how we smooth peak, and it's all driven by having better data and better data models. And I think that's the inspirational point about what can we do to manage and develop better infrastructure. What we did in Smart London, I think the thing we're proudest about in London, is make public data available for other people to figure out what they want to do. And the London Data Store, there's a portal you can go online and have a look. We've got about 800 data sets now streaming out on all sorts of attributes, right down to the street level: crime rates, smoking quit rates, bin cleaning rates, air pollution, health. And it's down to others to match that data and make something of it. And Transport for London has put out something like 500 apps from people in the street building stuff. City Mapper came from this, and we use City Mapper here in Hong Kong. Two guys from Google in London figured this out once we made the London Data Store. That's a liberation of data on infrastructure to allow new industries to grow. While we were doing this, we collected data, and we started to see peak problems from another angle. One of the ones which was curious was the rapid growth in white vans, little delivery vans, around the streets of London in the last 5 years. And we said, why is that? And it correlated very closely with the rapid rise of e-commerce. People having their little boxes delivered any time of the day. We then looked at what the consequences of diesel vehicles were. So an evidence base coming from this data. And at the moment, about 9,000 people die every year attributed to air pollution in London. Having another 8% of diesel vehicles due to e-commerce is just going to exacerbate that problem. So the Agile Urban Logistics project was one that the Smart London Board launched, not for the Mayor's office to figure out what to do, but for the entrepreneurs and the academics and the businesses to do that. Arup has been heavily involved in this project. We also said, and we saw a nice example from Andrew, we needed to use BIM in better ways. And I won't dwell on this very much because you've already seen another example, but last August we launched the London Infrastructure Map. All of the major works projects are now recorded. We're trying to build a BIM behind that and link all of that data together in an old city so that we can plan and prepare and be more predictive about our maintenance. So that's a quick shot at what we've been doing with Smart London, using data and making data active as data as infrastructure. Who's playing in this game? And this is perhaps my moment to try and be a bit shocking after lunch. So one of these 8 companies, I bet, is going to be the world's first trillion-dollar business. How many companies in this room think they can become $1 trillion capitalization? Put your hands up. Okay. Please, within the next 5 years, Terry. I'd love it to happen from this room. Jeff Bezos at Amazon is able to burn $1 billion on an experiment that fails, talk to his shareholders, and increase his share value. How many companies in this room have spent $1 billion on a research project that failed? So now let's just try and calibrate where the competition's coming from, because Amazon, and in this part of the world Alibaba, have the best logistics networks we've ever dreamed of. And it won't be long, if we're not already using them for our infrastructure projects, before we have to use them because of the economics will be so compelling and the data that's there will be so compelling. And I don't know if anyone from Amazon or Alibaba is here, but I hope they are, because I hope we're going to be collaborating and working with those companies. I don't have time to do all the other shocking bits about these companies, except to say that who sucks up all the talent that we might want to use? Now, which company has the most valuable employees in terms of share of market cap? It's Snap, £80 million per employee. And I looked at this and thought, well, the second one is Facebook, and that's 40 million. If I look at IBM, which is a great company, it's $400,000. And what are your companies worth in terms of each employee? I bet they're not even $400,000. And when I'm looking at my Imperial College students and where they're going to go and work and how much value are they going to create, you can see where the answer is. So we've got some scary things happening. And the last point about this is Google here, because Google just won a major planning project called the Toronto Waterfront through Sidewalk Labs. And some of you may not have heard of Sidewalk Labs. And they're competing directly with this industry. Right, I've been told I've got 3 minutes. I'm going to go very fast. So the other side of this is the entrepreneurial side, the startups that might not be in this room. So here's a project of a driverless car in Greenwich from the Smart London Board. You could have logged online and had a ride in that. And Blink, a student project, which is now a business, which is a gesture-based communication aid for citizens in the street with autonomous vehicles so that we can communicate together. Where did that come from? It didn't come from one of our companies. It came from entrepreneurs. Sensing, little sensing patches from entrepreneurs. A whole range of other entrepreneurial activities. Flock, by the way, is insurance for drones in cities using real-time dynamic data. It didn't come from the insurance industries. So I think Andrew Chan's point just now about the ecosystem and connecting in to the hot topics and for us to bind those into our programs is incredibly important. What does this mean? What does machine learning and this new environment mean for jobs? So here are the London taxi drivers striking because Uber's come to town. And Boris Johnson had a big fight with Uber, actually. 50,000 drivers in London, not taxi drivers, but ordinary drivers, registered to become part of the Uber network. Another 8,000 or 9,000 vehicles on the street clogging up the streets in London, and the taxi drivers complained. What's Uber doing with its money? It's working on driverless cars. It's going to put everyone out of employment on this picture in 10 years' time. It's better about striking about one from another. So there are some big questions about how this world of data in our infrastructure is going to reshape jobs. I happen to think, and certainly the sort of presentations we've seen today, that it's not going to do many of our companies out of work. I think it's going to augment them. And I've been, as some of you know, working on innovation processes for many years and looking at how new tools will augment them. And I can see a big opportunity here, and we've already seen some of the presentations of how data can augment the way in which we can design, plan, operate, and remodel the environment around us. But I would suggest the great institution of civil engineers, the great academic institutions, Hong Kong U, Imperial College, Cambridge, need to remodel how they're training and educating people for this world. And if we think about data science, civil engineers need to be data scientists too. We need new skills in order to get our hands on this material. MIT produced a really nice report on AI experts. People who can train algorithms, right? People who can explain algorithms, people who can sustain them so they do the right things and learn from one another. And there's a really new combination there of how data is being manipulated in models so that it can be useful when it's being predictive. We also need spaces for humans. And I've taken some pictures here from Airbnb, from IDEO, from some incubators. And these are the spaces where data and digital come together with physical in very creative ways. And I don't see that in some of our cities. I went to a place called Silk Mills yesterday here in Kowloon. And it's a refurbishment of an old silk factory. And it's rather wonderful because it's going to be a design incubator. I think it'll look something like one of these pictures. I hope there's a lot of data bouncing around there. And I hope it's connecting into challenges that come from this industry about what to do with infrastructure. So I also think we need to remember the human scale of how ideas are worked on and developed. And the final point is I think we'll need some new regulations and standards. I've got some scary images here about what data might be doing in the world. The Economist in the summer had a front cover saying nowhere to hide. This was a special issue on facial recognition technologies. can be extremely useful for securing access and can be used for ways that we might shudder about. What are we doing about these aspects when data is being applied to our infrastructure? How many of us in our companies or our universities are involved in those discussions? One of the things I worried about a lot, and when I handed on Smart London Board to the new Chief Digital Officer that London's appointed, I said we spend a lot of time looking at the upside. How do we innovate with data to remove problems like peak loading? We spent almost no time at all at looking at the downsides, the failure modes of these integrated systems, and the regulations we might need to avoid some of the disasters that might not be, I think Jean's point, somebody's responsibility or anybody's responsibility. We know they're there, but who is catching that? And maybe that's something that the institution should really promote and deal with. I hope I've just given you a flavour of some thoughts about data as infrastructure and how it might affect our infrastructure, and I'll stop there. Thank you.